In this video, I'm going to discuss the valve body on the PDK transmission. I'm going to cover how to remove it, how to install it, and I'll also cover how to completely disassemble it. We'll have a look at the solenoid removal and testing of all of those. Also, at the end of the video, what I'm going to do is completely pull apart the entire valve body and list all the components and everything that are inside and take measurements and that sort of thing. So there's going to be a lot of detail at the end, which is probably not going to be relevant for most people. But the problem is there are so many components in this. If you're not really careful, it's easy to get things mixed up. So I'm just going to take a whole bunch of measurements of all the valves and springs and that sort of thing, and I'll list those all at the end. If you plan to work on this stuff, there are a couple of things that are very, very important. The first one is cleanliness. You cannot afford at all to get any grit or any contaminants inside this thing, because this is driving all the hydraulic pressures throughout the entire transmission. The valves and the machining in this are extremely fine. The clearances are small, the tolerances are small, and if you get damage done by contaminants, then that's not going to be good. The next thing is that on the underside of this there, where this joins the transmission, the machine faces are again very, very fine. This is all aluminium, or it's an aluminium alloy, which scratches and dents surprisingly easily, and it's the same stuff that the transmission casing is made out of. So you can't do any damage to that at all, because the whole thing relies on really accurately sealed faces where the contact faces are, and if there is any damage at all, your transmission's just not going to work. I'll talk about some of the things that I do to keep it clean and to stop damaging things, but enough said, you just need to be very, very careful. The way the valve body is put together, as you can see, there's an electrical harness that runs down the back here that runs to all the solenoids. The valve body itself consists of three main parts. You've got the valve body part that holds all of the valves and springs up the top here. In the middle is a separator plate, and then on the bottom side there is the channel plate, and the channel plate is the thing that then drives the fluid to the appropriate spots on the connecting parts of the transmission. All of these screws here hold this sandwich of the channel plate, the separator plate, and the valve body together. There are about half of these that hold the whole assembly to the casing itself, and there are a whole bunch that hold the sandwich together only. I'm not sure if you can notice, but there are different size bolts here. There are the larger headed ones, which are T40. There are also an M6 bolt. They're all the ones that hold it to the casing. The smaller ones, which are T27, and they're an M5 screw, hold the sandwich of the valve body, channel plate, and the separator plate together. To remove the valve body from the transmission, we're going to leave the smaller ones intact, because that's just holding the sandwich together, and I'm going to remove all of the larger bolts. There are a couple of reasons why I change my fluid, the clutch fluid especially, so regularly in all my transmissions. First one is valve body operation, and the second one is clutch engagement. And as we pull this thing apart, you'll notice that the pistons are very finely machined, and the problem with clutch fluid is a lot of the debris circulates in it. It doesn't get filtered out, and as you can imagine, as these things are moving back and forth, they're going to wear the bores out. The pistons themselves are made of anodized aluminium, so they tend not to be the thing that wears. It's the bore that wears, and obviously as you get leakage, and also they start to ridge inside the bores, so the pistons don't move particularly well, and then you end up with problems, because clearly this thing can't send the correct pressure downstream that it wants to, regardless of what the solenoids or the computers are doing, if the valves won't move correctly. And getting rid of that debris as often as possible out of the valve body is one of the major reasons why I change my fluid so often. The problem with dealing with these things when you are pulling them apart is you might be going to a specific part to fix or to check, and the rest of it you just want to keep super clean. I find cling film is really, really good for that. So for example, if I wanted to test these solenoids, I've removed those, Now what I'm going to do is just get some cling fill and wrap it all up. It'll be covered in oil and that's fine, but it's going to keep it clean so you can just unwrap it and install it straight away afterwards. Because if this is left out in the open, it'll get grit and dust and that stuff on it, which you just don't want. The way the solenoids and valve bodies seem to work, the pressure that's supplied by the pump is going to be very high because the clamping pressure required for your clutches is in the order of 200 to 300 psi. The pressures that the solenoids work at is much lower, 60 to 70 psi. It's 4.7 bar is the maximum they're rated to. I think the black ones, these are rated to 5.5 bar. My old eyes can barely see that, but these are all 4.7 bar. And what seems to happen is that these act kind of like a relay, to use an electrical analogy, in that they seem to get a reduced level of pressure to the snout of each of them here, and depending on whether or not it's activated or not, it either allows that pressure when it goes in there to either come out there or there, and depending on the type of solenoid that it is, which then, if you look at the valve body here, you can see we get the pressure in the snout there, and it either comes out of there, or in this case here, it can be vented out the other side there. And so what normally happens with these is there's a pressure reducing valve somewhere. It looks like it could possibly be this one in here or that one in there. Beyond my pay scale to really kind of work that out. But then depending on where pressure from these ports go to via the channel plate and the separator plate to the other side, it will then activate different valves to then allow reduced or full pressure to go to the different components. So for example, as I said, the clutches need a lot of pressure. The lubricating gallery is going to use a lot less. I would imagine that's probably going to be the order of 50 or 60 psi. It'd be interesting to know what it uses for the shift rods, because I can move those with my thumb. I can just get to the end of those and just push those easily. So they clearly don't need that much pressure to move those around, and that's going to be adjusted via the solenoids anyhow. When we're removing the valve body out of the transmission, it's really critical that we do it in a controlled manner where it just gently gets lowered, so we don't do any damage at all to the sealing faces of the underside of the valve body assembly and the transmission casing, because there's no gasket or anything there. That needs to be perfectly sealed, because if leakages, things just aren't going to work right. We also need to lower it initially, probably about that far or so, so I can disconnect the electrical connections on all the solenoids. So there are a bunch of different options that are available to how we could do that, and I definitely would not suggest you just try and hold it by hand, because this thing is relatively heavy. It's going to be covered in oil and greasy, and then try and remove all the screws, because that's going to be a recipe for disaster. So options available to you that I've tried before and they've worked. This is the something that I used on another transmission removing a valve body years ago. I basically just bolt this to a transmission jack, and then I can turn these so they're at different heights, and then put that on the valve body itself. So when it's still in place, I can have everything all nicely lined up and supported, and then I can remove some screws and have the thing lowered. Normally what you would do is you would remove all of the screws except sort of 3 in a triangle, and then gradually lower those down a little bit at each time until they're completely removed, then lower the whole thing down. Other options that are available to you, something that it suggests in the workshop manual, is to use a 95mm M6 bolt. So I would remove probably that one, and that one, put the 95mm bolts in there, then remove all the others and lower it down onto that. And once it's lowered down onto that, then I can remove the electrical connections, and then remove those last 3 bolts and lower the thing down. Or if you don't have bolts that long, maybe some M6 threaded bar like this, where I can do the same sort of thing, remove those 3 screws, put those in, put a nut onto the end of this, and lower it down a bit, so I can then have that supported on a nut on each of those threaded bars, remove all the other screws, and then I can just gradually lower those nuts and lower the thing down. Entirely up to you what your method is going to be, but there are a few options available. To disconnect the electrical connections, there are obviously 8 solenoids here. These are all exactly the same, except for this one here is a little bit different. So these ones here, and be careful with these because they can get a bit brittle over time. All you want to do is just pull out that like that, and then just wiggle that down, and that just pops straight off. With the one in here, I'm going to do, there's sort of a lug in there that's sort of going to get in the way. On the edges there, you just need to sort of get a little pick tool and lift that up like that. And then we want to push down at the bottom. Okay, like that. And then, once we get all those free, the whole valve body can come out. And once the valve body is removed, this is what you'll see. These are obviously all the channels where the underside of the valve body here routes the different pressures from different places to the different parts of the transmission. You can see the electrical harness that runs around here. It's going to be screwed in a couple of different spots there. This one here is your temperature sensor, so that's a thermistor in there. It's just a tiny little baby thing down there. From what I understand, early on in production, they had some problems with these, so there is a kit from Porsche that allows you to replace that. So the way you would do that is remove the valve body, disconnect those two screws there. That whole harness will then just dangle free, and you can splice in a new temperature sensor there. When you're installing the valve body, what you'll need to do is lift it to a position like where we disconnected the electrical connections before. Connect all the electrics and then raise it into the transmission. This is difficult to do by hand. I would absolutely recommend using some sort of jig like this, which is going to hold it up so you can lift it up, still have access to everything underneath, so you can connect everything, and with that sitting on a transmission jack, then just gently lift that into place. Otherwise, it's going to be easy to either drop it or do damage to the underside. So I would absolutely recommend that. That's been pretty successful for me in the past using that method. I haven't connected the electrics here just to show you the way to connect all of this. So once all the electrics are connected, we're going to lift it up into place. And then we're going to start putting some screws in. I'm going to put some just generally in there just so it's supported. But then to put it in the correct position, there are these two holes here on the side. This one here doesn't have a screw thread at the bottom, but they're designed to take a 6mm bolt or a 6mm dowel or something like that, and then you wiggle it around until it slots in the correct spot down the bottom. This one here has a thread at the bottom. So it's the same thing, and then you're just going to put that in place. And those two are basically the dowels. So what I'm going to do is screw this one here down, because that puts now everything in the correct alignment underneath. And then once I've done that, I'm going to screw these down, just gently put all of them in place, and then that one can be removed and I can put that in the last hole. When you are torquing these, what you first want to do is make sure all the bolts are in and just gently seated. The book talks about using 1.5 Newton meters, which is next to nothing. So what I would do is I would just put these in by hand and just gently by hand with the same level, very gentle torque, so everything's seated nicely. And then I'm going to torque it down. The torque spec for this is like an initial tightening of 1.5 and then 8 Newton meters. And the tightening sequence, in the book it has, because there are 20 bolts and it tells you which sequence to do it, but basically it starts in the middle and it sort of goes around in a pattern like that. So from inside to outside is the way you want to torque these, the idea being that the valve body gets seated perfectly flat against the face underneath. With the solenoids on the valve body, there are 4 different types. Obviously they're color-coded or they're a completely different shape. Black ones, what they call an MV solenoid, they're a 7-volt solenoid, and they are either an on or off type deal. The others, what they call EDS solenoids, are graduated, so I think they get a pulse width modulation signal from the TCM to adjust how much they let in or let out, and some of them when they are off will allow full flow, some of them when they're off will allow zero flow, so they're sort of in reverse. Removing them is relatively simple. There's this bracket here which is held on by those 3 screws there. Same thing here except held on by those 2 screws. You remove the screws, and because there's a little lug that sort of sits in the bottom here, we need to wiggle these out slightly and then the whole thing will come out. I'll just do this one to show you. Now I've already loosened these. These will have 6 Newton meters on them, and they're a T27. And I find the easiest way, once you've removed those screws, is just to sort of, because that'll be a little bit loose like that, just get a screwdriver in there like that and just wiggle that out like that. And that'll just pop those free. And once it's out far enough, the clip will come out. You can see those little lugs there are the things that hold it into the slots. And then we can remove the solenoids. And they've got 2 O-rings on them, and you can just wiggle those out. Now, don't worry about getting them mixed up, because they can only go in the one spot. So a white one won't go into an orange hole, etc. The last one in the center here, 2 screws, and again, they just come straight out. It has 2 slightly longer screws. There we go. I'll put some part numbers up on the screen now for the individual part numbers for each of those. Some information about the solenoids if you want to test those. The black one is an MV, so it's an on or off. These others are graduated depending on the signal that's coming from the transmission module. But enough said, all we're going to be able to do is test them on or off, and whether or not the flow is correct and if there is any leakage. The black one, the MV, is a 7-volt solenoid, so for that I'm just using 4 AA batteries just in a battery pack there. That gives me 6.5 volts, so that's going to be good enough. All these other 3 are 12 volts. So I'm just going to use a standard 12-volt battery. The way these work is the pressure goes in the front, and I'm going to seal around the second O-ring on these, because depending on the type that it is, it'll either allow flow through or not, but it vents out the back in this gap in here. So it's the same on that one and the same on that one there, except that one vents out the back there. So I'm going to seal around there, and what you'll notice is for the orange ones that with no electrical power applied, they will vent. And when you apply the electrical power, they will close off. So that's the same for those, both of those orange ones. For the white ones, when it's sealed around here, with power not applied, it won't vent, and with power applied, it will. And for the black one, it's similar to the white, except what we're going to do for the black one is we're going to seal around there, because it vents out of this one here. So these it allows to go through either here or here, whereas this one seems to just be a case of whether it's either open or closed. So if it's open, it'll allow, if electrical power is applied, to vent out of that one there. And if it's closed, so no electrical power, nothing gets vented through it at all. The ratings of these solenoids, the EDS solenoids, which are those 3 there, they're rated to 4.7 bar, that's about 68 PSI. The black MV solenoid, which is a 7-volt one, it's rated to 5.5 bar, which is 80 PSI. I'm going to just test these at 60 PSI because I don't know how accurate my air compressor is. And the way I'm going to do that is I've got obviously jerry-rigged a connection to my air compressor, which is permanently open except for the pressure regulator on the compressor itself. I'm going to fit those, I'm going to tighten the clamp around that, and then I'm going to apply the electrical power once I apply pressure. When you're connecting the electrics to all of these, if you look at it like that, so the writing's the right way up, the contact on the right hand side is the negative, on the left is the positive. It's the same for that one there, so that's negative, positive, and obviously the same for all of those. So 60 PSI set, and now I can just put my contact up in there, and that works fine. And to check leakage with these, you can put your ear down to them and check that there's nothing leaking out of those at all. And that works fine. With that construction of the valve body, you can see the channel plate, the bottom one here, the separator plate in the middle, and the valve body part on the top that holds all the valves. They've got these spots in here which enable it to be pried apart. And the way this works is that the separator plate has a bonded gasket on it. So there's no separate gasket. And so what you want to do, because getting hold of these is going to be, I reckon, impossible, because clearly they're not a spare part that's available. If you are separating this for whatever reason, what you want to try and do is do it in a way that keeps that bonded gasket in place. And I'll show you what I mean once we get the thing apart. But what we're going to do is we're going to remove all these screws and then pry this thing apart. Now once you remove all the screws, and I've just left one in there because I've removed all this previously, so it's not bonded anymore, but you'll expect that it'll all hold together because of that bonded gasket. And then what we're going to do is use these pry positions, and I would suggest using a plastic pry tool so that we get in here and just open those up. And we're going to separate one side and then the other. Now this one here, which is the one that holds the valves, it doesn't have anything that's going to spring out. This one here though does. It's got a bunch of one-way valves and things in there that we want to sort of keep in place and sort of, I'll show pictures of what it looks like just so you can know where they need to go back to. I would suggest once you get everything apart and everything's in the right place, take a photo of it so you know exactly where it needs to go to when you put everything back together. And there we go. So that has sprung apart. But I would suggest popping off this one first, so getting in at the edges here and separating that. Be really gentle, because as you'll see, when I lift this up, we're going to see that. We've got one-way valves here, which will be stuck in here. In here, there's this little mesh piece, and there is a one-way valve, which will go into that position there. So there, the pieces and how they're going to look. In addition to that, you've got these dampers, and we'll pull these out in a moment, or accumulators, depending on what you want to call them, that can be pushed out from the other side. But they're the pieces that you'll need to take note of the positions of them and install them in the correct position. Once you get this out, I would suggest immediately bagging this up, cleaning it, and keeping it aside, ready for installation later on. And you can see the bonded gasket here, and one of the reasons why we want to be really gentle about pulling this apart is because if I can get it apart like this, where the bonding doesn't break and none of it ends up on this side like this, then I can reuse this. If this breaks apart, then I'm in a bit of trouble and I'll need to replace this. Or it's possible, according to Sonax, which is an aftermarket transmission part for valve body company, what they suggest is if you chemically remove all of the gasket and then make sure these are perfectly surfaced, then you can just mount it straight on there. Because on other transmissions, they don't have this bonded gasket. It'll just be bolted straight to the separator plate. So, but obviously, if you can get it like this, where it's completely separated and there are no breaks in it, that's the ideal. And once one half is off, then we can pry away the other half. Again, I've pulled this apart and I've covered it in oil so it won't bond again. That comes apart. It's the same on the other side, and there's all your valve body. All these pieces on the channel plate will just pull off. The springs for these are just on little lugs and they'll just pull straight off. These will be jammed down here a little bit, but they come out really easily. This one here just sits there, so you can just pull that out, and the little filtery thing, put those in bags. If you want to remove the accumulators or dampers here, just on the underside, you'll have a hole where these correspond to. What these are, they're a little rubber sort of thing that can fill up with oils, so it's to dampen the onset of flow. And so you can just push those out. I'm just using a really skinny little drill bit just to push that out. And that's what they are there. So there are 6 of those that can be removed. The workflow that I use that has always been successful in the past, again, it's entirely up to you if you decide to do this, but to keep all this stuff clean and organized, when I remove something, I'll have everything in a line. I'll have buckets of solvent ready to go with compressed air, so I can pull a component out, wash it straight away a number of times, blow it with compressed air so it's dry, and then put it. I use Ziploc bags or cling film, but certainly Ziploc bags for small components where they're labelled is, I find, a very good way of organising everything. So then by the time you come back to install it, you can just lightly grease things, put them into place and put everything together and install, so everything's nice and clean. When you are putting this back together again, this is what I would do. I'm going to have the channel plate sitting down like that. I'm going to put in all the pieces, so all of these one-way valves, etc. Make sure that one's sitting in there like that. And then I'm going to fit my bonded gasket over the top. Those one-way valves will fit into holes. It's pretty obvious where they go to. Make sure they slot in there. Make sure everything's perfectly clean. I'm going to then fit this one over the top like that. It's still going to be sitting there on those springs. Then I'm just going to get one screw just in the middle and gently push it down and put that into place. Not all the way, like pretty much all the way in, but loosened off maybe about a turn or so. And with that one screw in there, this thing can now move around, but then what I need to do is align using these dowel holes to the side. So what I'm going to use is a 6mm bolt, and I'm going to push it down and wiggle it all the way down so it goes all the way through. Same on the other side. And with those in place, now I've got all three parts aligned correctly, and I can put all of the other bolts in there. And when I put all these bolts in, there's obviously large holes and small holes. The small ones are the ones where I need to put the screws. The big ones are just fall straight through, because that's where it's going to go and get bolted to the transmission housing. And in a similar way to how I described how you would install the valve body to the transmission housing, I am going to put all of those in. I'm just going to very gently seat those all the way down, and then I'm going to torque them. Now the torque specs for these, there's nothing listed in the workshop manual, because they don't talk about pulling this thing apart. However, these exact screws are used in loads of different ZF valve bodies. These 5mm ones, M5, and they take 6 Newton meters. So what I'm going to do is just gently tighten them down. I'm going to start at the inside and work my way around in sort of a spiral pattern, so inside to out, and then I'm going to torque those to 6 Newton meters, again in that same sequence. To disassemble the valve body, there are basically 3 different varieties of way these things are held in. There's this variety up the top here where you've got this wire clip that goes in from the top. It's held in and around that little knob, which is on a plug, and then when the clip is removed, the plug comes out, and then the spring and the piston can come out. There's this variety here where there's this little tab where you push it out from one side, and then once that's removed, the spring and the piston will come out. And there's this variety here where you've got these metal clips. When you pull that out, on the other side of that is this plastic plug, which is kind of shaped like a barbell. And they're very tight in there, so you'll need something to push those out. I'll show you what tools I use for those. And then once that comes out, then the piston and the spring will come out. You want to try and use tools that aren't going to scratch things, so I try as much as I can to use bits of timber and tools like this to remove things, but sometimes you're going to have to use metal things if that's all you've got on hand. For example, this is the metal tool that I use, which is just from a piece of fencing wire, because when I remove these plugs here to get these out, I'll need to push this down here and rotate that around to push it forward and work it forward until it pops out the front. If you're doing that, then obviously be very, very careful of that machine surface that you don't scratch or do any damage to that. To remove these ones with the wire clip on the end, you'll need to push this in a little bit to take the pressure off it. Sometimes that can be quite a bit of pressure, so you may consider using a dowel or something like this to push on that. But all you're going to do is push on that and then just lift out the clip like that, and then that will come out. Now, these doesn't matter if you grab hold of these with a pair of pliers to pull these out. That one's just popped out nicely. Sometimes they get jammed in there, so you may need to just grab hold with a pair of pliers to remove that. And then when everything comes out, note the orientation of everything. The spring in that case is going to come out first, and then if you just gently tap, you should see that work its way down. If it doesn't want to come out, sometimes you'll need to, for example, in this case, I'll just get a little piece of timber. This is just a pop stick and just help that on the way and move that down like that. Sometimes also you can apply some compressed air at the end here to push it along. Whatever's required, just to gently have that come out. Be really careful because obviously we don't want to do any damage to it. And then it's obviously the reverse for installation. Make sure that has some ATF on it when it goes back inside. Feed the spring and piston in the correct orientation. And then the plug's going to go in on the end. And then we're going to compress that in far enough to put our clip all the way on the end like that. These on the end here with this metal tab here, they're the simplest. You're just going to put your finger on the side, push that up a little bit, and then you can just pull that out. A little bit of spring pressure there, but not too much. And then there's the spring there, and then you tap. Again, that should come out. If it doesn't, again, you might need a bit of compressed air to get that thing out. For install, the thing that I find is easiest to get that in far enough. So I just use a small socket. In this case, it's a 6mm socket. I'm just going to push that in there like that. Put that so it's against the spring and holding it in place, and then I can just look at that there and make sure that wiggles over the outside of the spring and push that down. These along here with these clips that hold that barbell shaped plug in place seem to be the most difficult to remove. The tool that I use to do this is this. It's a piece of fencing wire bent at 90 degrees. That's probably, I don't know, maybe 5 or 6 millimeters long, and the idea is I'm going to stick that down and rotate that around to push it forward. You're not going to be able to see it here, but at the end of that plug is the end of the piston. To get your tool down in there later on, you may need to get something in here and push that rearward so this can slot down in place. It'll go against the spring pressure, but there's not much pressure there. The important thing is we don't touch the outside face of the piston. The ends are fine, but you don't want to touch anything that's possibly going to scratch either the bore or the outside sealing face of the piston. The first thing I'm going to do is remove the plug with something that's not going to scratch it. And then I just rotate it to push it down. You'll lift it up, go to the next one, and do the same thing. Now sometimes at the ends, because the clearances are so fine, I might just need to have a look at it and adjust it to check that it's centralized, because that one's just gone a little bit off center and got stuck. Just adjust that. And then out it comes. And that's that plug there. The clip would have fit in place like that. And then from there, everything should just come out. Note the orientation, that was the spring second. And of note for the orientation, and that's the bore that just came out of, that one there. You notice all these little slots, that's going to be at the sealing end here, and that big long bit of metal there, that's generally where the spring goes, just in case you get confused. To put that back in, just be nice and gentle to put those in. And then again, because the clearances are so tight, these can sometimes get a little bit out of center. You just need to put them in, and then they will push all the way home, and then you can put that clip into place. The one that is a little bit different is this one here that has no spring in it, and this is a spring-loaded sort of half ball valve, which makes the valve inside either sit in this position or sort of that position. And all of this stuff is exactly the same, but we need to remove this little spring-loaded valve here first. And what I found is if I just put a screwdriver in there that fits nicely and just pull that out, it just pops out straight away. It's just got a little O-ring, and that's just a little ball there. But once we remove that clip and do what we did before, that thing will just slide straight out. In the absence of other information about how they number and that sort of thing, all of these valves, This is the way I'm going to number them because there are 14 of them total. So starting from left, just going to be 1, 2, 3, 4, etc. to 11 at the end here, and then 12, 13, and 14. And what I'm going to do is pull out all of these, give you the dimensions of the springs and the pistons and how it's all put together, etc. Valves 1, 2, and 3 that slide in from the rear seem to be identical. The spring 30 millimeters long, the wire 0.9 millimeters, and all of these pieces here 10.9 millimeters across. This one's 8.9 millimeters across, and the whole valve is 103 millimeters long. Valve 4, which goes in there, the wire gauge 0.7 of a millimeter. It's 22 millimeters long. The sizes on the piston 10.7, 8.9, and the whole thing was 50 millimeters long. The orientation is like that, so the spring goes in first. Valve 5, the spring 0.7 millimeter wire, 22 millimeters long, and whilst it seems very similar to the one in 4, slightly different it seems. That one is 10.5. That one there is a smidge over 9 with a total length of about 50 mils. Valve 6 is 50 millimeters long, and each of these lumps is 9.9 millimeters. The spring is 44 millimeters long. The wire itself 1.1 millimeters, and that stopper is going to be on the end with that metal clip. Valve 7 is a funny one in that the piston is comprised of 2 parts. So I've got my spring, wire is 0.7, it's 22 millimeters long. I've then got this piston, $10.3, 8.6, 49 millimeters long, and then this one here, 10.3, 16.9 long, and then the dumbbell stopper. Valve 8 seems to be identical to valve 7. Valve 9 doesn't have a spring, it's 77 millimeters long. Each of these is 10.4, that one's 8.4, and that's the one with that spring-loaded ball. Valve 10, the spring comes out first, so it's a different orientation to all of these. The spring is 0.8 millimeters by 29 millimeters long. The valve itself is 76.5 millimeters long. All of these are 10.6. And the bit at the end, 9.8 millimeters. Valve 11, 40 millimeters long. The wire is 1.2 millimeters. The valve which goes in first, spring second, at 11.9. Same there, 8.4 millimeters. Valve 12 has this stopper. The spring goes in there with it inserting in that orientation. $14.9, 14.9. This one here is a bit smaller, about 14.4, and that one there is 14.9. The one at the end, 8.7. It's about 60 millimeters long. The spring gauge 1.2 millimeters. And it's 38 millimeters long. Valve 13 looks like this, with this big funny plastic stopper on the end. The spring is 1.6 millimeter wire, and it is 56 millimeters long. And the piston itself, the end bit, a smidge over 13, 15.9, 15.4, 15.9, 15.9. And valve 14, spring goes in first and it slots inside the piston there. Spring wire is 1 millimeter. Spring length 27. The piston 13.7. For all three of those. 10.3 for the bit on the end. Length of 67.5 millimeters.